We're going to start looking at complex fractions. Now, a complex fraction just means that there's fractions within fractions somewhere. So this first example here, that's considered a complex fraction because we have a fraction in the numerator and a fraction for the denominator. Now, when we have ones like this, what's really happening is it's 2/3 divided by 1/5. And when we divide with fractions, we take the reciprocal of the second one, change it to multiply, and then just multiply them. So this one would end up being 10/3. Now when we have complex fractions that have variables in them, we do the same process. This one looks really ugly. We've got a fraction in the numerator, a fraction in the denominator. So what you'll want to do is write it out sideways. Well, that's really going to be a multiplication problem as long as we take the reciprocal of the second one. It's always the second one we take the reciprocal of. When I get to this point, I'm going to go ahead and cancel some things out, like this x right here. I'm going to cancel with that x. And it looks like I can cancel this x with one of these x's, so I'd still be left with one x there. And it looks like that might be it. So then across the top, I'm going to have 4x. And across the bottom, I would have 15y squared. Double check to see if you can cancel anything out, and we can't, so that would be it for that one. So those are our simple complex fractions. Now we get into ones that are just a little bit more difficult, and the reason for that is because they've got a sum or a difference as part of their numerator or denominator. We're still going to start the same way though. We're still going to write it out sideways. So it's 20 over x plus 1 divided by 5x over x squared minus 1. Same thing's going to happen again. We're going to flip it and we're going to multiply by the reciprocal. So I'm going to have 20 over x plus 1 times x squared minus 1 over 5x. Now at this point, I need to factor anything that I can factor because right now I can't start canceling. Like this x over here with the 5, I can't cancel with one of these up here because this x squared minus 1 is a family. So first I have to factor it so it's in terms of multiplication. That's going to factor into x plus 1 and x minus 1. It's a difference of two squares pattern. Now I can see if there's anything I can cancel before going on. And remember, you can cancel anything on the top with anything on the bottom as long as we have a multiplication problem. So the 20 and the 5, I'm going to cross cancel and reduce to a 1 and a 4. The x plus 1 and the x plus 1 are going to reduce. I cannot cancel this x with that x from the x minus 1 because the x minus 1 is a family. You have to take it all or nothing. So what I'm left with on the top is 4x minus 1, and on the bottom it looks like I just have an x. So that would be my answer for that one. Okay, here's another one. You're going to do the same thing. So pause the video, write it out sideways like we did right here, and then flip it and multiply it, factor it out, and see what you can all cancel out. So pause the video and give that a shot. Alright, the first thing I did on this problem was I rewrote it out sideways. That's what I have here in the red. So instead of being two fractions stacked on top of each other, I wrote them sideways with a division sign. Then in the green, I took the reciprocal of that second fraction and changed my sign to multiply. The blue, I factored all the different pieces I could. I can't factor the 3, and then I can't factor this x plus 5 over here, but I factored the other two expressions. And then I looked for things that I could cancel. And remember, you can only cancel something from the top with something from the bottom. So in the purple, I canceled out my x minus 2's. Now right here, these x plus 5's, they do not get to cancel out because they are both on the bottom. Now if one of them had been on top, they would, but since they're both on the bottom, they cannot cancel each other out. So what I was left with on the top is this final part down here in the purple, where I have 3 times x minus 3 over x plus 5 times x plus 5. And then another way I could write that is I could write the denominator as x plus 5 squared. Alright, now we're getting into ones that are even a little bit more complex. And the reason that these are more complex is because right down here in our denominator, we don't have just a single fraction anymore. We have an entirely separate problem. We have a subtraction problem here. So what we have to do is we have to only focus on the bottom to start with. I'll come back and I'll erase that so we can see what the top is in a little bit. So we are only focusing on the bottom. And what we need to do is we need to do this subtraction problem. So if you remember, we need to find that LCD so we can add these two fractions. Well, when I factor my 4 out, it turns into a 2 and a 2. X plus 1 just stays x plus 1. So my least common denominator is 2 times 2 times x plus 1, which ends up being 4 times x plus 1. Now I need to go back to my original fractions and ask myself, what is this first fraction missing from my least common denominator? Since it's only missing the x plus 1, I'm going to multiply the top and the bottom of this first fraction by x plus 1. So I would have 1 times x plus 1 over 4 times x plus 1. Now I need to jump to the second half of my fraction, and I have to ask myself, what's this denominator missing from my least common denominator, and that's a 4. So I need to multiply the top and the bottom by 4. So 7 times 4 gives me a 28, and on the bottom I'm left with 4 times x plus 1. Now that we have the same denominators on our fractions, we can go ahead and simplify them out. So I would distribute this 1 out, and I would just have x plus 1 here. So I really have the problem x plus 1 minus 28, and combine those like terms, and I get x minus 27. And then my denominator, I have 4 over x plus 1. Now keep in mind, that is only the denominator of my entire problem. But what I have done is I have gotten it down to a single fraction. We started with 2 separate fractions, which we don't want. We want to combine them into a single fraction. Now that I've got it to this single fraction, I can go back and look at what my numerator is. I'm going to carry my numerator over, so it was 15 over x plus 1, and we haven't touched that because it's a single fraction already. So 15 over x plus 1. Now I'm back to a problem like we did way earlier. I've got a single fraction on top, a single fraction on bottom, so I can go ahead and start writing it out sideways now. So I would end up having 15 over x plus 1 divided by x minus 27 over 4 times x plus 1. And now I want to see if I can factor any of the numerators or denominators. And it looks like they're already all factored out, so now I want to try to cancel things out. And I can see that I can cancel out the x plus 1 and the x plus 1. Now the 15 and the 27, you might think that you could reduce by 3, but this isn't just a 27. It's part of the family because of that minus sign. It's x minus 27. So it looks like I'm left on top with 15 times 4, which is a 60. And on the bottom I have x minus 27. Alright, here's the last style of one. I call these the pure evil complex fractions. And the reason for that is because you've got separate fractions on the top and separate fractions on the bottom that we have to deal with. With a problem like this, we're only going to focus on the numerator first. So completely ignore this denominator for now. Pretend it doesn't even exist. We'll come back and deal with it later. What you have to realize is you have 2 separate fractions again. We have a fraction right there, and we have a fraction right there. And all of that is within this bigger fraction. So the first thing we have to do is combine those two. So we have to do the addition piece of this first. So I'm going to just focus on that part. We have 3 over 2x squared plus 6x plus 18 plus x over x cubed minus 27. Now I need to go about and try to find my least common denominator. Well, to do that I need to factor first. On this first one, I see that I can pull out a 2, so I'm going to go ahead and pull out a 2 first, make it a little bit simpler. And then I'm going to see what this will factor into. Looks like... Nope, it's not going to factor any farther. So this is all the farther that one factored. Now I need to go and I need to factor this one. This is one of our special patterns from your flip books. It's the cubed pattern, So you need to rewrite it as x cubed minus 3 cubed, and then follow your pattern in your flip book. So it says we have x minus 3 times x squared plus 3x plus 9. Now my least common denominator, I need to have a 2. So I'm going to have a 2. I need to have this x squared plus 3x plus 9. Look at my second group. I need to have an x minus 3. But the good thing is I already have this expression over in my least common denominator, so I don't need to have it again. Now I need to go back to my problem and I need to ask myself, what is this denominator missing from my least common denominator? And it's only missing the x minus 3, so I'm going to multiply the top and the bottom by x minus 3. When I do that, I am going to have 3 times x minus 3 over 2, then the x squared plus 3x plus 9, and then the x minus 3. Now I need to go to my second fraction. I need to ask myself, what's this denominator missing from my least common denominator? And it's only missing the 2. So I need to multiply the top and the bottom by 2. So I'm going to have 2x over my common denominator. Now I need to go ahead and simplify. So I need to distribute my 3 out. So I would have 3x minus 9. And I need to add that to 2x. So I really end up having this whole thing as 5x minus 9 over my common denominator. Okay, that is only the numerator of our problem. So what we have to do now is we have to go back and focus on the denominator. Alright, now that we have the numerator done, we can ignore that. And now we have to do the same type of process with the denominator. I have to focus on doing this subtraction problem. So I really have 5x over 3x minus 9 minus 3 over x minus 3. I need to find the least common denominator. So I'm going to factor both of the denominators, and I can pull a 3 out of this one. And this other side is already factored, so my least common denominator, I'm going to have 3 and then x minus 3 from right here and there. Then as I look over here, I already have the x minus 3, so I don't need to add it again. Then I need to go back and figure out what is this denominator missing. Okay, then I need to go back and figure out what is this denominator missing from my least common denominator. And it isn't missing anything, so it just gets to stay by itself. It's going to be 5x and then 3 times x minus 3. Then I have to go look at this denominator and ask myself, what is it missing from my least common denominator? And it's missing that 3, so I need to multiply the top and the bottom by 3. When I multiply the top by 3, I'm going to get 9, and on the bottom I have 3 times x minus 3. Now that I have the same denominator, I can go ahead and simplify the tops, so I have a 5x minus 9 over 3 times x minus 3. This is now the denominator of my complex fraction up here. So we have taken this problem here, which had 4 separate fractions in there. It had 2 on top and 2 on bottom, and we have combined it so that we only have 2 fractions. Now we can do what we do with a simple one. We just write it sideways and then cancel things that we can cancel. So we are really going to have 5x minus 9 over 2 times the x squared plus 3x plus 9 times x minus 3. And I'm going to write it sideways, so I have the division. And then I have that 5x minus 9 over 3 times x minus 3. I'm going to change that into a multiplication problem by multiplying by the reciprocal. Alright, when I rewrite this and multiply it by the reciprocal, I see that I can start canceling some things. The x minus 3 and the x minus 3 cancel each other out. The 5x minus 9 family and the 5x minus 9 family cancel out. I cannot cancel this 3 with that 3 right there because the 3 on the bottom here is part of a family. So on top I'm left with 3, and on the bottom I'm left with 2 times the quantity x squared plus 3x plus 9, and that would be my final answer for that one.